Hello, how are you? I hope you're doing well. Welcome back to my new topic. In today's video, I'm going to solve some numerical problems based upon the refractive index. Let us have a little revision. You see, this is the incident ray and this is refracted ray. And this angle is called delta. Delta nothing but angle of deviation. And this angle is R. R equals to angle of refraction. And this is a I. I is nothing but angle of incident. And here is relationship I equals to R plus delta. Therefore, R equals to I minus delta. This is the first relationship between the angle of incident and angle of refraction. Also, the refractive index denoted by various symbols like N21 R, the mu 21 R, N21. These are the various symbols we use to denote the refractive index. Now, N21 equals to, all symbols stand for the same. The various books are using various symbols, various denotions. So these are the denotions. This is nothing but refractive index of second medium with respect to first medium. Now, refractive index is obtained by using the angle of incident and angle of refraction, that is by using Snell's law. So that is nothing but refractive index of second medium with respect to first medium is equals to sine I upon sine R. By using this formula, we can easily find out refractive index. So sine of I and sine of R equals to refractive index of second medium with respect to first medium. Now, one more thing, when the light is traveling from first medium, this let us call it a medium 1 and call it as a medium 2. So when the light is traveling from one medium to another medium, what is changing? What are the things are changing? You see that speed of light is changing when the light is going from one medium to another medium, and the wavelength of light is changing. What is not changing? The frequency of light is not changing when the light goes from one medium to another medium. Only the two things are changing. Three things are changing. One is the direction, another is the velocity, and that is the speed of the light. And the third one is the wavelength of light. So these are the things are changing. So we can correlate the refractive index with the speed of light. So that is the refractive index of the second medium with respect to first medium equals to speed of light in the first medium divided by speed of light in the second medium. So when the light traveling from one medium to another transparent medium, then the speed of light is changing. And similarly, we can correlate this with the refractive index, that V equals to n lambda. So n into lambda 1, n into lambda 2, because the frequency is not changing, n and get cancelled. So we get the another relationship, that is the refractive index of the second medium with respect to first medium equals to lambda 1 upon lambda 2. So these are the various relationships we are going to use to solve the numerical problems. And so let's solve now some few problems, 5 to 10 problems based upon the refractive index of the medium, but all problems are different. They will clear your concept. Example number 1, when a ray of light travels from air to glass, if the angle of incidence is 60 degrees. So while reading the problem, you keep on drawing the diagram. So what is the diagram here? This is the medium and it is a normal. You have to draw like this. An angle of incident. This is a incident ray and this angle, the angle between ray and the normal, that is a I, that is the angle of incident. An angle of refraction is given, even that is a angle between refracted ray and the normal, that is a R. So what is given here? I equals to 45 degrees and angle of refraction is given as a angle of incident is given as a 60 degrees and angle of refraction is given as a 45 degrees. Now we need to find out refractive index of the glass. So call it as a first medium, call it as a second medium. So refractive index of second medium with respect to first medium, that is mu to 1. That is nothing but refractive index of glass with respect to air. So that is a refractive index of glass with respect to air. The same symbol can also be written like this, refractive index of glass with respect to air. Now this is nothing but formula sin I upon sin R. That is equals to sin, that is a 60 degrees upon sin 45 degrees. Sin 60 nothing but root 3 by 2 and sin 45 nothing but 1 upon root 2. Therefore, refractive index of glass with respect to air equals to root 3 by 2 can be written as a root 2 into root 2 and this can be written as a root 2 upon 1. Root 2 get cancelled here. That is equals to root 3 by 2 equals to under root of 1.5, that is nothing but 1.224. So under root of 1.5 equals to 1.224. Therefore, refractive index of glass with respect to air, refractive index of glass with respect to air equals to 1.224. It has no units. It is a ratio of two angles. Therefore, refractive index has no units. And refractive index also called index of refraction. So there are the two names. Either refractive index you can call or index of the refraction. So refractive index of glass with respect to air equals to 1.224. I hope you understood this example. Now let us go for the example number 2. Here I want to warn you one thing. While the problem is given, be specific that about angle of incident and angle of refraction. There must be angle of deviation as well as. So be careful whether it is angle of refraction or angle of deviation. So depending upon that you have to decide whether it is a delta or R. Okay, let's move to the example number 2. If the refractive index of glass is 1.5 and velocity of light in vacuum is 3 into 10 raised to 8 meter per second, find the velocity of light in glass. So first of all, what do? You frame the rough diagram. This is the given glass and the light is traveling, and when the light is traveling from one medium to another medium, the speed of light is changing. So we have here the value given as a n21. This is a symbol, or you can also write down like this, refractive index of second medium with respect to first medium. The first medium is vacuum and the second medium is glass. Therefore, the same symbol can be written as refractive index of glass with respect to vacuum. And this symbol can also be written refractive index of glass with respect to vacuum. So this is equals to the velocity of light in vacuum upon velocity of light in glass. So otherwise you can write 2 to 1 because it's a first medium, it is a second medium. Whichever suit to you. Either write vacuum or glass. I wantedly written so that you come to know the distinction. You can also write down the refractive index mu to 1. So this is the velocity of light in vacuum. The refractive index is given as a 1.5 and velocity of light in vacuum is 3 into 10 raised to 8 and velocity of light in glass. We have to find out velocity of light in glass. So velocity of light in glass equals to 3 into 10 raised to 8 divided by 1.5. So that is equals to 3 divided by, that is a 30 upon 15 into 10 raised to 8. So that is equals to 2 into 10 raised to 8 meter per second. That is the velocity of light in glass. So this way we can find out. Never confuse yourself with these symbols. Otherwise you can write like this: velocity mu to 1 equals to v1 upon v2. This is a very simple one, but when you are writing the exam, in examination you need to write the steps. You have to write down glass, vacuum, etc. So there you have to write down the vacuum as well as the glass. But first, if you mention medium 1 is a vacuum, medium 2 is a glass, then refractive index of 2 to 1 if you write, then we will also do. So the final answer, velocity of light in glass equals to 2 into 10 raised to 8 meters per second. Let us move to the example number 3. Now, example number 3 here. If ray of light incident on the surface of water making an angle of 60 degrees, the ray after refraction deviated through an angle of 25 degrees towards the normal. This is important. Away from the normal or towards the normal. So the ray is deviated towards the normal. Find the refractive index of water. Sin 60 and sin 35 values are given here. Otherwise, if not given, you can calculate by using log tables. First of all, draw the diagram here, and this is the normal, and these are the rays incidenting, and angle of incident is equals to 60 degrees. Now, so this is the an angle of deviation. The deviation is nothing but this angle delta, and this angle equals to r, and we know that relation, and I equals to 60 degrees, and we know that I equals to r plus delta, and delta value is given 25 degrees. So delta value is given as a 25 degrees. Now 60 equals to r plus delta, because to find out the refractive index we must have the two angles. One is the angle of incident, angle of refraction. Angle of refraction not given, so we have to find out. How to find out? By using this relation. What is that relation? I equals to r plus delta. Now delta value is 25 degrees. Now delta r value, r equals to 60 minus 25, that equals to 35 degrees. So we got the r value equals to 35 degrees. Now we need to find out refractive index. So refractive index of water with respect to air, or it can also be written like this: refractive index of water with respect to air. This is equals to what? Sin I upon sin r. This is the formula. So sin I nothing but sin 60 degrees, and sin r nothing but sin 25 degrees. Now we'll put the values. Now here the values are given: 60 degrees and 35 degrees. If not given, you can calculate from your log table. So sin 60 degree nothing but 0.8660, and sin 25 degrees, r equals to, sorry, it is not 25, it is a 35 degrees. So sin 35 degrees nothing but 0.5735, and I already calculated this result, that is nothing but 1.510. So this way the refractive index of water with respect to air equals to 1.510. This is what the solution is. Example 4, a tub is filled with water of height 14 centimeter. The apparent depth of the needle kept at the bottom found to be 10.52 centimeter. Find refractive index of water. Okay, so we have the tub and here is the water, and here is the, we got a needle here. Needle is kept at the bottom, and this is the true height, that is 14 centimeter. But when somebody is observing from the top, and he found that the depth of the needle found to be 10.52 centimeter. So that is the apparent depth. Apparent depth is the H2. This is the H1, and the apparent depth, that is the H2. So needle was found to be here. So step 1, let H1 is equal to, let H1 is equal to what? Actual depth, and H2 equals to apparent depth. Apparent depth means what? The which is not real one, which is a illusion. So that is the apparent depth. Now refractive index of water with respect to air is nothing but actual depth upon the apparent depth. So actual depth is nothing but 14 centimeter, and the apparent depth, that is a H2. H2 equals to 10.52 centimeters and H1 equals to 14 centimeter. So here we write down 10.52. Now this is equals to 1.33. Therefore, refractive index of water equals to 1.33. Here in the previous example as well as this example, we use the word water, but it is equally valid for every other transparent liquid, like like any other liquid which is transparent, through which you can see and the light can pass. For all liquid, this formula is applicable. The water, because it is a very common liquid, therefore in many examples you will find water, but not necessarily water. There can be the any other liquid. Example 5, refractive index of water with respect to air is 5/4. What is refractive index of air with respect to water? First of all, we make denotation here. So let mu WA, that is refractive index of water with respect to air, and this one is the refractive index of air with respect to water. I have written other symbol also here. Whichever you like, select one of them. Don't learn all the three symbols. Select one symbol and stick to that one. Otherwise, you will get confused. I have written here wantedly all symbols, very popular symbols here, but one which is taught in your college or you use regularly, you use that symbol. Don't use all these symbols. Now we know the relation. The relation is that refractive index of water with respect to air into refractive index of air with respect to water is always equals to 1. And now they have already given to us refractive index of water with respect to air, that value nothing but 5/4. So here 5/4 into refractive index of air with respect to water equals to 1 implies refractive index of air with respect to water equals to 4/5. This is required solution. Here is example 6. If absolute refractive index of two media A and B are 1.5 and 1.25 respectively, the speed of light in medium A is 2 into 10 raised to 8 meter per second. Then find the speed of light in medium B. How will you find out this? Quite easy. Here the absolute refractive index is given. What is the absolute refractive index? If the refractive index you are finding out with in relation to vacuum, that is the first medium is vacuum and second medium is glass, water, anything else, but the first medium is vacuum, then the refractive index so calculated is called as a absolute refractive index. Now here we need to find out the speed of light in the medium B. How will you find out that? Quite easy. Here is the solution. So we got the two medium here, medium A and medium B, and absolute refractive index. So the refractive index of medium A with respect to vacuum, that is given as 1.5, and the refractive index of the medium B, that is absolute refractive index with respect to vacuum, that is given as a 1.25. And the speed of light in medium A, that is the speed of light in medium A, is given as a 2 into 10 raised to 8. We have to find out speed of light in medium B equals to how much. Now formula, refractive index of medium A with respect to vacuum. If you don't write anything, it is vacuum, understood. So that is equals to velocity of light in vacuum upon velocity of light in medium A implies 1.5 equals to vacuum. We don't know the velocity of light in vacuum, so first we need to find out, and VA given as a 2 into 10 raised to 8 implies velocity of light in vacuum equals to 1.5 into 2 into 10 raised to 8, that is equals to 3 into 10 raised to 8 meter per second. Now after this we will use this relationship, that is we came to know velocity of light in vacuum is 3 into 10 raised to 8 meter per second. Now again we use refractive in absolute refractive index of medium B equals to velocity of light in vacuum upon velocity of light in medium B. So refractive index given already as a 1.25 and velocity of light in vacuum given as 3 into 10 raised to 8 upon velocity of light in medium B. So velocity of light in medium B equals to 3 into 10 raised to 8 upon 1.25. So when you divide it, you get here 1.4 in 2.4 into 10 raised to 8 meter per second. So that is velocity of light in medium B equals to 2.4 into 10 raised to 8 meter per second. Example 7, refractive index of medium A with respect to B, that is refractive index of A with respect to B is equals to 3 upon 4, and refractive index of B with respect to C is equals to 5 upon 4. Find the refractive index of C with respect to A equals to question mark. Now we know that refractive index of A with respect to B nothing but VB upon VA. So that is equals to 3 upon 4, and refractive index of B with respect to C nothing but VC upon VB, that is nothing but 5 upon 4, and refractive index of C with respect to A nothing but VA upon VC equals to question mark. So what we will do now, you will multiply all the three relations 1, 2 and 3. So first one is refractive index of A to B and refractive index of B to C, and refractive index of C with respect to A equals to VB upon VA into VC upon VB into VA upon VC. So this value is 3 upon 4, this value 5 upon 4, and this value refractive index of C with respect to A. Now this cut down, this cut down, this and this cut down, and that is equals to 1. Now further simplifying, so refractive index of C with respect to A equals to 1 into 4 into 4 divided by 3 into 5, that is 16 upon 15. This is required solution. Further you can simplify, that is 1 and 1.06. Hello, after these examples, have you got the confidence? I hope you can now manage this type of problems. Start doing the questions from your textbook. If you are not getting, refer the question to me on my email address provided in the description box. You see that if you start doing the problems and if you struggle for the problem, then only you will get the solution. If you just see the solution and if you want to get the similar type of questions and you are able to solve the similar type of question, then we can't call it as a learning. You should be able to solve the different problems from your textbook. Solve them, try them, struggle with the solutions, struggle with the problem. Then only you will become the master. Otherwise, you will keep on learning by just similar type of questions, so that we don't call it as a learning. So keep on doing the problems. If you find any difficulties, I am there with you. Don't bother about physics at all. Meet you again with another topic. Till then, keep on doing the problems. Bye bye. Wish you good luck.